Good afternoon, sir.
Hello.
Good afternoon, sir.
Hello. Am I audible?
Yes, sir, you are audible.
Yes, sir.
Okay, okay. Just we'll wait again. Some more students want to join. Only 5 members are here. It's okay. Uh, Students are still on joining. Mm, Only 10 students are present here. It's fine. So, dear all students, actually, yesterday's one lecture and previous to yesterday's on Tuesday one more lecture I have to lost due to I am busy with the meeting in yesterday, and you are busy with the Python lab session on Tuesday. So today that's what I have to actually I didn't have a lecture today, but due to missing of previous two lectures, today I am going to engage your lecture. So dear all students, just I have to check, am I audible? And uh, my screen is visible to you?
Yes, sir.
Okay, fine. Okay, fine. Thank you. So, dear students, already we have to covered a very small unit, that is introduction to microprocessor, and we are in the continuation with second unit of microprocessor, that is 8086 microprocessor. In that also, I taught two topics from the second unit, that is architecture of 8086 and internal operation of 8086. Entire architecture as well as internal operation, it means the working functionality of 8086 with a pin diagram we have to study. And today I am going to start with next topic, that is machine level instructions. So in the machine level instructions, again mainly two type topics are there. that addressing modes and instruction execution timing. So these addressing modes already you studied in your diploma course. Same you have to repetition here. I think you may not studied is instruction execution timing. So both addressing modes, totally 5 to 8 addressing modes, mainly 5 addressing modes, and categorize it into 8 to 9 addressing modes we are going to study, and that each instruction of the microprocessor execution timing we are going to study today. Okay, very important topic. So now I will move to the notes. These notes already I shared with you. That is okay. So in that we studied previous these many topics. That is okay. I'll just 1 minute I will go through it. Features of 8086 we studied, and we studied architecture of 8086, all bus interface in it and execution in it we studied. In that explanation of bus architecture, up to that we studied internal operations, and in that we have to study flag register also. Totally 9 types of different flag register. This diagram shows the entire summary of the flag register. By taking this diagram, just you have to write 1 or 2 lines each flag register. Automatically it becomes about 1 page of your answer, more than enough. And internal operations also we studied architecture of internal operations. In that there are 3 fetches: first fetch, second fetch, third fetch. In the first instruction, second instruction, third instruction of even and odd address. Okay. So today we are going to start with machine level instructions. So in the machine level instructions, mainly we are going to study addressing modes and instruction execution timing. Before that, we have to come to know actually what is the instruction, because machine level language instructions. So as we know, the instructions means what? There is a some commands given to a processor to do particular task. Just a second. To do a particular task of the microprocessor, we have to use some mnemonics, opcodes and operands. Those are nothing but the instructions. So this instruction is divided into 2 groups again, that is of the bits or the fields. Based on that, bits or the fields. So first one we say opcode. Opcode is nothing but operational code. So actually we have to use the one code what is going to do the operation. That is nothing but op operational code. That one we have to syntactically represented as opcode. It indication the operation code. Second one is the operands. So only opcode is there. Then what is the use? To do the operations, two or more than two operands are there. So needs operands, those are nothing but operands. It indicates the information needed to carry out the task. Needed to carry out the task, that is operands. So the operands may contain data, information, address, value, or pointer, indirect pointer to data. Any value it may contain, that is nothing but operands. Sometimes the memory location also we have to say operand to do the performance of all the arithmetic and logical operations. Okay. So whatever the operations is used to particular task, those are nothing but operands. As you know, for example, a plus b is equal to sum, or sum is equal to a plus b. So sum is what? It is a opcode. Operation is going to be do it, and that a and b is what? That is the operands, and the symbol plus is nothing but operations in a sequence of sum equal to a plus b. Like that, how you are used in the mathematical form, same way you have to use it in the microprocessor for the instructions, which is nothing but containing a bit fields, that is opcode and the operands. I think I make clear you about the instruction. So that general instruction format, if we have to say the instruction, then how the instruction will look into that, that one we have to study. So that is nothing but first one, opcode. Opcode is nothing but what? It is a mnemonics of instruction. And the operands, the operands may be one or more than one. Operands may be one or more than one, but at your level, in the degree level, you have to use it maximum two operands. Max to max three operands in only one or two case, and remaining all sector you have to use it either one operand or two operand. Very easiest for your syllabus. Okay. So this is the machine level language basic concept, and now we have to start with addressing modes. As your syllabus, I have to start with addressing modes. Okay, one topic addressing modes and instruction execution. Today both the topics we have to cover, 1 hour for addressing modes and remaining 1 hour for instruction execution timing. Okay, so now we'll start with addressing modes. So what are the addressing modes? Addressing modes are nothing but if you want to do any operations, it must and should need for addressing, because the particular location of the value or of the data or of the information present in the computer memory. So where that exactly the data is going to be stored, is going to be present in the memory, that one we are going to fetch is nothing but addressing mode. Fetching the data from the memory is nothing but that is addressing mode, the mode of addressing, and we are going to retrieve the data, return back to the data, that is addressing mode. So in that addressing mode, the operand is satisfied in the instruction is called as addressing mode. So that addressing modes of 8086 broadly divided into again two categories. One is data related addressing modes, and the second one is branch related addressing modes. So the data related addressing mode is a normal, just we are going to do the manipulation with the operands by using operations. And the branch related addressing modes are, it is related to memory. In the memory we have to, because there is some kind of memory segmentation with a different locations of memory, we have to use some branches to interconnect with each other. That is nothing but branch related addressing modes. So two category main in the addressing modes, that is data related addressing modes and branch related addressing modes. Okay, so here in the addressing modes again we have to come to know with data related addressing modes at first. What are the data related addressing modes? So totally there are 5 main data related addressing modes. Just one by one I have to explain. Please all of you be more concentrate on this. So the immediate addressing modes. In this immediate addressing mode, first one, register addressing mode. Clear notes I will provide you, don't worry. Okay, and indirect addressing modes, third one. Fourth one, indirect addressing modes. Direct addressing modes, third one. Fourth one, indirect addressing modes. And the in that again indirect addressing modes, two types: register indirect addressing modes, register relative addressing modes, and based index addressing modes, base index relative addressing modes, and at the last one, implied addressing modes. There are totally 5 addressing modes of data related. There are totally 5 data related addressing modes are there. So the first one is immediate addressing modes. Immediate addressing, the name itself is says that whatever the operations using the operands to do the particular operation, immediately it should be happen without taking any much time and without taking any much memory. Within a short period of time it is going to be happen. That is nothing but immediate addressing modes. Suddenly the data is going to be fetched from the memory location and going to do the operations along with the instructions of microprocessor. So in that, the operand or a data is specified in the instruction itself. That's what it is immediately happen, and it provided the data may be either 8-bit or 16-bit long, because the 8086 is a 16-bit manipulation and it is obeys all the rules of 8085. That's what 8085 is a 8-bit. So the 8086 addressing modes of immediate addressing modes obeys that 8-bit as well as 16-bit long. 8-bit, it means that higher nibble 8-bit and lower nibble 8-bit. 8 plus 8, it becomes again 16-bit. So that instruction format of immediate addressing mode, just there is a one instruction with the data. For example, you are using move cl comma 12h. So this is the one example for instruction. So the move opcode is here, move cl is here first operand, 12h is here second operand. It means that the value of 12 hexadecimal data, h in the sense hexadecimal data of 12 value, you are going to assign to the CL register. It's actually C register. There are 6 registers, A, B, C, D, E. 6 registers are there along with accumulator, and if it is C with L means lower level of C register. If it is H means higher level of C register. So the move CL comma 12H, the meaning is the value hexadecimal value of 12, you have to store it into the CL register. That indications I have to show here. 12H is go and sit into CL register. In the same second instruction, that is move CX comma 1 2 3 4H. So here I have to use it X in the sense what? Either it may be a low L or it may be a high H, L or H. This is for the 16-bit instruction, and first one is for the 8-bit instruction. That's what I have to use it. 8-bit, 16-bit, only L with 8-bit, X with X means either L or H, both 16-bit purpose we have to use it. So immediately this value you are going to transfer into the C register at the lower level, that is immediate addressing mode. Why we call it as immediate addressing mode? The value directly you have to shift it into C register. This is the immediate addressing mode. Next one, the second category of data related addressing mode, register addressing modes. So in the register addressing mode, you have to use one register to transfer the data. That's what we have to say, it is a register addressing mode. So in this register addressing mode, the operand or the data is specified using the register only in the instruction. So that data may be of 8-bit, which can be provided either it may be a AH or AL with the A register, either higher nibble or the lower nibble. Here with the B register, same way higher lower. Here with the C register, higher lower. Here with the D register, higher and lower. Okay. So for the 8-bit register, H and L you have to use it. For the 16-bit register, just you have to use it X instead of H and L, AX, BX, CX, and DX. Along with that, source index, destination index, stack pointer, and the base pointer with the 16-bit registers, isn't it? Okay. So that is a register addressing mode. So the diagrammatically you have to show here which is a register. In the instruction only, we have to take register, and that register to the data we are transferred. How? Just one example. Move CL comma DL. So in the previous example, direct addressing modes you have to compare. Here you have to took 12 value, or here you have to hexadecimal value, right? But in the register addressing modes, you have to take register only in the value, place of value at the addressing modes, because in the first one there is direct addressing modes, but here it is a register addressing modes. It means that the value already present in the register. From the register, you have to transfer the value to the source place. Okay. So for that, we have to use it. We have to say this one as register addressing modes. So it means that whatever the value, whatever the data is containing the D register at the lower level, that is transferred it into C register at the lower level of C. That is the meaning. So the data is moved from DL to CL. Here, right to left with the instruction. Right register is DL, and that is transferred it into CL register with the upcode of move. Same way in the second example, that X. So this is CX. Actually, this is a CX. There is a mistake is there. Please all of you correct it in the notes. Okay, make it as a CX comma BX. So whatever, sorry, AX it is AX. So that AX comma BX. So whatever the value of BX is there, containing the value of BX, that is transferred it into AX register, isn't it? Okay. So we have to use the register to transfer the data or a value to the source index. That's what we have to call it as register addressing modes. Very clear, very clear. Am I right? So next I will go to the third category of data related addressing modes, that is direct addressing mode. So first one is the immediate. Immediately you have to transfer the value directly, and the second one is register addressing mode. In that you have to transfer the data by using the register, and the third category, that is direct addressing mode. Here the address of the particular location or the memory of a value or a data directly you have to assign to the registers. That is becomes a direct addressing modes. In that, because the addressing, whenever the address bus or data bus comes, that time it is 16-bit. Okay. So in this mode, the 16-bit effective address of the operand or the data specified in the just instruction, that is in the instructions only we have to use effective address EA, in the sense effective address that is in the memory, or it is a memory means what? It is a data. So this is a direct addressing mode. That data is directly given to the instruction through the effective address is called as direct addressing modes. For example, always the direct addressing modes we have to use the square bracket. We have to use a square bracket for the particular value. Just naming notations you have to compare in the direct addressing modes. If this is the square brackets are there with the value, that one you have to say direct addressing mode. So move CL comma, it means that this is the location of data address 4321 is a, it's a location, it's a pointer, it's an address, whatever the value is containing in the memory. So that memory address is going to be assigned to the CL register. It means that 43213 is address. That address is directly assigned to CL with the data segment. DS in the sense what? Data segments. That is direct addressing mode. Same way in the 16-bit CX, higher nibble 5678H with the move CX. Okay. So what is this? Actually, this is not a value. It's the address of the memory location where the value is present. Don't confuse it. Once again, I will repeat you. Where the value is present in the memory location, that value address is nothing but this one. That address you are going to assign to the register. So it is a direct addressing modes. So in the next fifth category, we will move to indirect addressing mode. First one is immediate addressing mode. Second one is register addressing mode. Third one is direct addressing mode. Now, fourth one, indirect addressing mode. So in the indirect addressing modes, again, there are three categories: register indirect addressing mode, register relative addressing modes, based index addressing modes, and base index relative addressing modes. So in that addressing modes, students, is it clear now, or any doubts you are arising? Because very important concept. Once you understand this concept, you have to write the microprocessor program. Nothing is difficult in that. Okay. If anything, anywhere you are not understood, immediately you have to stop me and ask the question, because very important concept today, whatever I have to explain you. Isn't it? Any questions, please? Dear students, am I audible?
Yes, sir.
Is there any questions?
No, sir.
Okay, okay, thank you. Yes, so in the indirect addressing modes, that first category is register indirect addressing modes. So you have to transfer the value array data by using a address indirectly to the source location. Indirectly to the source location, that is nothing but indirect addressing modes. So through the register, that is register indirect addressing modes. So in this mode, the microprocessor uses two base registers, that is base pointer and base pointer register, as well as two index register, source index and destination index. Okay, to provide the offset of addresses. So the effective address of data is in a base register, that is bx, and it may be bh or bl, and in the index register, that is specified by the instructions. That instruction is going to be decided in the computer memory. So for example, the bx is nothing but data segment and bp is nothing but stack segment. You have to indicate it, bx as a data segment and bp as a stack segment. So there is a one effective address. In that effective address, using the indirect addressing modes, there's an effective address, that is bx, which is the data segment, si, which is the source index, and di, which is the destination index. These are you studied in the execution unit of microprocessor architecture. Okay, just to remember it. So the naming, the diagrammatic syntax, we have to say that instruction with the register, and register with the effective address. That effective address in the sense what pointer, there is a star is present here, that star which is pointer addressing to the memory where that particular data is located in the memory, where that the particular data is located in the memory. That is nothing but effective address. That effective address is holded by the register. So through the register, we have to given to the instruction with another register, that is the indirect register addressing mode. It is very important, please concentrate on this. Okay, yes. So for example, there is a move instruction with a CL register. Here you have to come up, there is a one register which can hold the address of another value data that is going to transfer to a CL register. So through the another register you have to transfer it is means of indirect addressing modes, means of indirect register addressing modes. That's what here also in the address location bx register is there to the source point CL register. So that bx value again you have transferred totally into the CL register. That's what we have to say, register indirect addressing modes, isn't it? Okay. So next, in the second category of indirect addressing modes, that is register relative addressing modes. So here one more extra we have to use it, that is base pointer with the base index and source point index, destination index, that is with the 8-bit displacement, or we have to say for higher nibble 16-bit displacement using extended in the effective address. So compared to previous as same, and one more extra we are going to be use BP, base pointer, pointing to the address of containing the register in the next value of the memory location of computer. Okay, so that is register relative addressing modes. So this one we have to indicate it like this. In the instruction only, register and displacement, that bx is nothing but displacement, register and displacement, and through the register we have to given to the address, that is effective address, that's what bx, bp, si and di, and finally we are pointing towards the data of memory where it is going to be containing, where it is going to be present in the microprocessor. That is register displacement is present in the instruction along with the address, and this entire summation, that's what I have to use the plus point, plus operational, right, plus point in the effective address. In the effective address again we are going to point it to data where that data is present in the particular memory. So that's what we have to call, this is a register relative addressing modes. In that MOVCL bx plus 4, so extra 4 is added here, and in the next example bp plus 12h, that is relative, whatever extra value we have added, that is relative. Bx is particular location plus fourth location, what the value is containing, so it is becomes a relative. That's what we call it as register relative addressing mode. Okay, so the next one, that is based index addressing mode. Third category of index addressing mode, that is based index addressing mode. Here we have to use either displacement or base pointer. Bx is the displacement or bp is the base pointer along with the effective address, so that with source index and destination index. So these four we have to use it in a register at the previous, but we have to separately use it. Bx and bp, displacement and base pointer, plus source index and destination index. How it is? By looking instruction with the base register, index register, and the register at index with the base register. Finally, it is going to be collected at the effective address with the pointing to the data of where the data is present in the memory. Very interesting. Okay, that's what we say, it is a based index addressing modes. So here bx, previous example we are using here value, right? Here we are using again the source index or destination index with a displacement or a base pointer along with the register. So whatever that displacement with the source index is containing the value of the address, that is going to be transported into C register by the data segment ds. Same way in the second example. Okay, ds means data segment, ss means stack segment. Either it may be from the data segment or it may be from the stack segment to the C register. If it is 16-bit, either we have to use the CL or CH. If it is 8-bit, we have to use only CL, isn't it? Okay, so next, the fourth category in the indirect addressing mode, that is base index relative addressing mode. Fourth category is base relative addressing mode. Here entire things is comes with all the relationals from the base, displacement, base pointer, source index, so destination index, along with the effective address. It is going to be find out to the particular data or a value. So in this effective address of an operand, the sum of register bx or bp contains index register si and di, or contains the 8-bit or 16-bit displacement. As previous here, bx is the displacement, bp is the base pointer again, plus addition of source index and destination index, again with the addition of in the effective address, that is either 8-bit displacement or 16-bit displacement based on 8-bit or 16-bit microprocessor. Okay, so that diagrammatically we have to show that base register with the index register with a displacement. So displacement directly we have to given to the effective address, and the index register we have to given to displacement or through a register, and same way in the base register also we have to given directly to here or indirectly to the base register to the effective address at the summation, and at the end of data or memory is going to be manipulated. So this is the four categories. So there are four categories in the indirect addressing mode: base index relative, based index addressing mode, uh, register relative addressing mode, and register indirect addressing modes. Okay, so totally there are four categories in the indirect addressing modes. So totally four addressing modes we studied. What are those? Immediate addressing mode, register addressing mode, direct addressing mode, and indirect addressing modes. Now I will move to the fifth category, that is implicit addressing modes, or we have to say implied addressing mode, fifth category of data related addressing modes. Okay, so in the fifth category, in this, the addressing mode in the operations are implied in, and where uh, the specified in the instructions. Okay, so here we have to say stc, set the carry flag, and cld, clears the direction flag. These two flags we have to use: set the carry flag or clear the direction flag in the implied addressing mode. So just one example is anything. Okay, so these are the some examples what we are solved here. So there is nothing in the instructions you have to use it. Just for very rare case we are using implied addressing mode, that is set with the carry or clears the direction flag. Already 9 flags you have to study: direction flag, carry flag, parity flag, auxiliary carry flag, sign flag. Okay, so all those these two are mainly used in the implied addressing modes. So and after that I have to prepare some problems here for to find the uh, sometimes they are asking for a single questions. So now in this addressing modes, again I will repeat you just for 2 minutes. Today I am going to start the addressing modes. In that addressing modes, I have to start with immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode. Again in the indirect addressing mode, relative addressing mode, direct and indirect. Again four categories we have to taught in that. Again the fifth one is implied addressing modes. Totally 5 addressing modes we studied and comes under data related addressing modes. Okay, so for example in that what we taught based on bx, displacement, and di, destination index, and si, source index, and ds, data segment. These are we have to study it. So in this example there is a given bx is 0158 and the di is nothing but 10a5 and the ds is nothing but 21,000. Displacement is 1b57. For the direct register, how to effective address, that effective displacement is nothing but what directly we have to take, that is a effective address. So effective address is 1b57 at given in the question paper. And the physical address, is nothing but what effective address plus data segments. So if what is the effective address, this is the formula you have to note down. Physical address is equal to effective address plus displacement. Just you have to note down. Okay, ds is this one. So here the effective address is given, that is nothing but a displacement 1b57, and the ds is value is also given 21,000. So 21,000 plus 1b56. Use the calculator, scientific calculator. You have to go through with base hexadecimal number. You have to add it 1b57 plus 21,000. That is the value of total physical address in the direct addressing modes. Next, is it clear? First one, just effective address is given 1b57. Physical address is the formula effective address plus ds. So that effective address is given 1b57 and ds is given 21,000. So addition of these two in the hexadecimal is we will get it this much value. Okay, So next one, register addressing modes. Here there is no any effective addresses. That's what we don't use any physical addresses. Next, I will move to the register indirect addressing. In that register indirect addressing mode, just we have to assume that the register is a BX or any register you have to take according to your convenience. But here the BX is given. That's what I have to take BX register, and the effective address register is nothing but 0158. That is 0158 directly with the effective address. So what is the physical address formula again? That effective address plus a data segment DS. So the effective address is 0158 plus the data segment is, this value is given 21000. So you have to add it these two value. You have to add these two value, you will get it. Okay, for the register indirect addressing mode. And in that register relative addressing modes, again you have to assume the register is a BX because it is given in the question. So here effective address is equal to, that is BX with 1B57, whatever is given in the effective address. So it becomes a again addition of 0158 plus 1B57 in the hexadecimal 1CAF. So that is the physical address. How you are going to find again? Effective address plus data segment address. Data segment is 21,000 is given. 1CAF what you have to found with the effective address A. So total it becomes a 22CAF addition. Just a minute. So next I will move to based index register. So in that we have to calculate effective address using the BX plus destination index. So BX is nothing but 0158 as we found earlier, and DI is nothing but 10A5 is given in the question. DI is 10A5. So finally we have to find BX plus DI. 0158 plus 10A5 is nothing but 11FD. So once we find the effective address, next the physical address is nothing but effective address plus DS. So the effective address is 11FD and the DS is given 21,000. So this is the value. So next one is the relative based index. So in the relative based index, that is BX is 0158, DI is this much. So and the effective address is nothing but what? BX plus DI plus displacement. So that is 0158 for BX, DI is for 10A5, and displacement is nothing but 1B57. So totally we have to get 2D54. Okay. So again the effective address plus the DS, that is 2D54 plus 21,000. We will get it this much value by the calculator, isn't it? So this is the problems how we are going to find the effective address and physical address by using different data types of data related addressing modes. So in the addressing modes category, we have to come to know it that sorry. So in the addressing modes, the first category, that is data related addressing modes. So again I will come to the point here, addressing modes. Yeah, this is the addressing mode topics. So in that addressing modes, we have to taught data related addressing modes. Okay. So in the data related address modes, just a summary of this, there are 5 main category. First one is immediate, second one is register, third one is direct, fourth one is indirect, and fifth one is implied addressing modes. And along with that, different kinds of operations, different instructions, and different kinds of problems. We have to check it out. Okay. So this is all about data related addressing modes. Next, I will move upon branch related addressing modes. Second category is branch related addressing modes. Okay, now we will go to it. Branch related addressing modes. Okay, yes, this is the branch related addressing modes. So in the branch related addressing modes, again there are four categories, two of each. It means that intra segment and inter segment, mainly two categories, intra segment and inter segment. So intra segment with direct and indirect, intra segment with direct and intra segment indirect, and inter segment with direct and inter segment with indirect. Totally main category is two, intra segment and inter segment. Again in that direct and indirect subcategories. So totally 2 into 2 is 4 category in the branch related addressing modes. So what are those 4 category? We will see it. First one is inter-segment addressing modes. So in the inter-segment addressing modes, either we have to use the 8-bit or 16-bit displacement. Along with that, here in the instruction only, we will use displacement or the instruction pointer. IP is nothing but what? It's an instruction pointer with the effective address. So in the data related, we are not using any IP or any instruction pointer. Okay. But in a branch related addressing modes, compulsory we have to use instruction pointer. What the pointer will do? The pointer will pointing to the location of any another data or the value. So that's what in the branch related addressing modes, compulsory we have to use instruction pointer. So this is the notations for in the instructions we have to use displacement and instruction pointer given to the effective address. From the effective address we have to find intra segment direct. This is intra segment direct. So again in the intra segment indirect, indirect we have to take it as, so that instruction with the addressing modes, instruction with the addressing modes with the effective address computed by addressing mode, effective address computed according to the addressing mode indirectly, not a directly. That's what we have to say. It is a indirect intra segment. Intra segment means what? Within, intra within, inter outside. Remember it. So inside direct and indirect, outside direct and indirect for the manipulation of memory in the addressing mode. That is with branch related addressing modes. So here in that indirect, indirectly we have to give an effective address to the addressing modes. So effective branch address and effective branch address for memory or for the registers to separately. So this is a intra segment indirect. So what we saw, intra segment direct and intra segment indirect. Next, inter segment outside. If you are going to do the outside, then control that core segment is compulsory again. So here it replaces the contents of instruction pointer with a part of instruction and the contents of code segment. CS is nothing but what? It's a code segment with another part of instruction. And also the purpose of this addressing mode is to provide a branching from one code segment to the another segment. One code segment to the another segment. It means that what? One memory location to the another memory location. So data is transferred from the one memory location to outside of another memory location. That's it. Intra segment. So that data is transferring, either it may be a direct or it may be a indirect. Okay, again it is two category. So in that intra segment direct, so that's what we have to use instruction with the offset. Why we are using the offset? Because one memory to the another memory we have to transferring. Inter segment means within the memory only it was happened within the same memory, but intra segment is within the different memory. That's what we are taking here. Offset along with the instruction pointer, be remember, very important again. Yes or no? So in this instruction, that is offset and the segment with the code code segment and the instruction pointer with a different point, that is directly through the offset address. That's what It's a intra-segment direct addressing mode in the branch related. So next, the last category, that is inter-segment indirect. So in this inter-segment indirect, it replaces all the contents of instruction pointer and the code segment with the contents of all two consecutive words. Okay, so in that, the referred using of any data related addressing modes except only the immediate and register addressing modes. So for that, in the indirect, which is outside the memory, so that's what intra segment indirect, that is instruction addressing modes with the effective address computed according with the indirect addressing modes, and that is with branch address offset and segment offsets, or the segment addresses consequently. That's what we have to say. Intra segment indirect relative addressing modes. So there are four main categories in the branch related addressing modes. Second category of branch related addressing modes, what are those? Intra segment indirect, intra segment direct, inter segment indirect, and intra segment direct registers. So actually these branch addressing modes are not that much uh, important for your level, but anyhow it is there in the syllabus. I have to explain it. Please you be remember with this. Okay, so dear all students, today whatever I covered, next is instruction execution timing. So before going to start instruction execution timing, I'll give you 10 to 15 minutes. Okay, still now, actually I am expecting more questions from you about this topic, because still I didn't got any single question from you. I am unhappy. If I got questions from you, then only I become happy. Okay, so what I do now, take 10 to 15 minutes time, and this addressing modes, whatever addressing modes topic I covered, mainly two addressing modes, data related addressing modes, branch related addressing modes. Again, in the data related addressing modes, five category: immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, implied addressing modes. Again, branch related addressing modes, four categories: inter-segment, direct, inter-segment indirect, and intra-segment direct, intra-segment indirect. All these 5 plus 4, 9 kinds of register addressing modes. You have to study it. Just you go through this 10 to 15 minutes. Any doubts, please always welcome to your doubts. After 15 minutes, I will start with execution timing. Okay. Again, I will taught execution timing on 40 to 45 minutes. Please go through 15 minutes to this addressing modes nodes. Anything else, please let me know. Yes, your time starts to start to study this addressing modes. Again, I will start after 15 minutes instruction execution. Okay. Yes, please. Any doubts, please let me know. Okay, that is fine. If no doubts, again I will started with the last topic, that is instruction execution timing. Okay, dear students, am I audible now?
Yes, sir.
Okay, okay. So again, after that also you have to go through these notes, scan well, study well. Again, any doubts are arises or you facing any problems, please let me know later. Okay. So now all of you come to this topic, that is instruction execution timing. Very important again. If any instructions are there for the microprocessor to do the particular operation or a task, that how much time it to takes, very important, because nowadays everywhere to queue, everywhere queue is there, no? If you go to ATM, queue is there. If you go to bank, queue is there. If you go to railway station, queue is there to collecting a ticket. If you go everywhere, even you go marketing also, now queues are there. For that, to maintain the timing, execution within the time, to complete the task within the time, that is very very important. So for that, now we have to study about the instruction execution timing of microprocessor, different instructions. So here in that instruction execution, I have to mention here for the basic execution of time, to assume that that instruction to be executed as already have fetched the value which is stored in the instruction queues, and otherwise the additional clock cycles are also required for the execution. So why the clock cycles is needed? As we already studied, the 8085 and 8086, the clock uh, that clock is built in, clock frequency is built in, right? There is no externally we are going to use here. So for that we have to necessary to come to know the execution of instructions. So in that I have to make the list. Just you have to remember, no need of to do the particular implementation. Just you have to remember effective address with number of clock cycles is needed for the execution. So direct addressing mode 6 clock we need, register indirect 5 clock, register relative 9 clock, and in the based index along with that 7 or 8 we need. and in the based index relative 11 or 12 we have to use it. Okay, so that is the time needed to execute the effective address. Just you have to rough idea, no, it is a particular value, just you have to remember, and this is helpful for to writing the lab examination. And later on, these are the some operations or the calculations in the effective addresses, just for on or off, either it is a 0 and 1, either 0 off, 1 means on, and 2 is for hexadecimal. Okay, 1 is for octal, isn't it? So this one table, just you have to go through it. This is the instruction execution, and a particular that addressing modes, different kinds of addressing modes, how much value is needed to execute, that one I have to mention in the table. Just you have to go through it. This is not that much needful. Okay, so this entire table you have to go through it. So after that, I have to made it here some calculations how to find the execution time, because these table values are there. Actually it is a one chart, one table. If we are, the questions are asking in the examination, they have to given this chart, otherwise they have to mention the particular given value in the questions only. Okay, so some examples I have to solve it here, how to find the execution timing of particular instruction. So this is the first one example. There is a add register to register, that is the result is. So for example, the given number 3, number of clock cycles is 3, and the execution time, if we have to find the execution time, this is the formula. All of you remember this. Please note down this formula, all of you. Execution time is nothing but number of clock cycle. It is a ratio of number of clock cycle to the clock frequency. How we are going to find the execution time? How to define the execution time? The execution time is nothing but it is a ratio of clock frequency to the number of clock cycles. Whatever I have to mention here in the page, execution time is equal to number of clock cycles divided by clock frequency. So the clock frequency by default it is 5 always. Why it is 5? To the microprocessor 8085 and 8086, we have to supply the power of 5 volt, right? We have to supply the power of 5 volt at the pin number 20 and pin number 40. Remember this. So we have to supply 5 volt power. That's what the clock frequency we have to consider by default as 5, and the number of clock cycles it is given. Number of clock cycles is given. So the definitions of execution time is nothing but it's a number of clock cycles to the clock frequency. So in our case, the number of clock cycles is nothing but 3 value, and the clock frequency is nothing but 5 value. So 3 by 5 is equal to 0.6 microsecond. 0.6 microsecond. So because it is 10 to the power of 6, 5 into 10 to the power of 6, if it is goes to the numerator, it becomes a 10 to the power of minus 6. So again it 10 to the power of minus 6 nothing but micro. So we have to measure in this microsecond. In the second example, so we have to see, that is add memory to the register. So here the number of clock cycles what he made in the addressing mode, that addressing mode is 9. Go to the table, it is available in the table. Addressing mode is 9. So that is the 9 where is that? Okay, the 9 plus effective address. What is the effective address? That effective address is based on that 12 cycles. So here 9 plus 12 is equal to 21. So the 21 by 5, again number of clock cycles you are getting 21. So what is the execution timing? Number of clock cycles divided by now clock frequency. Number of clock cycles is 21 divided by clock frequency is 5. So 21 divided by 5 is nothing but 4.2 microsecond again. So in the 21 cycles of byte or a word operations, with a word at the even address, that is 4.2 microseconds in the second example. And again you are going to find the total addressing mode, that is 9 plus 12 as you were given example, and that is a 4 whatever you have to finding the value in the execution time. So totally 9 plus 12 plus 4 is equal to how much? That is 25. So that total 25 cycles of a word or address is going to be find out. So the 25 divided by 5, 25 is what? It is a number of clock cycles divided by 5 is clock frequency. So 25 by 5, finally you have to getting 5 value, 5 microseconds. That is the execution timing. So in this way, again 2 to 3 examples I have to given here. Okay, one more example. In the third example, at the add register to memory. So here also the number of cycles is 16 plus 8. He is given as per the register basic with addressing calculations, and 16 plus 8 is how much? That is 24. So this 24 divided by 5, number of clock cycles is 24 divided by clock frequency is 5. So 24 divided by 5, you will get it 4.8 microseconds, and total number of cycles is 16 plus 8 plus 4 plus again 4 for the extra cycles in the add register. So finally you have to get 16 plus 8 plus 4 plus 4. So 16 plus 8 is 24. 24 plus 4 is 28. Again 28 plus 4 is 32. 32 cycles of word or signals you have to getting. If it is 32, total number of cycles, and what is the execution time? Execution time is again 32 divided by 5. Total number of cycles divided by clock frequency. 32 by 5 is nothing but how much? You have to getting 6.4 microseconds. So these are the execution timing, how the particular instruction is going to be execute within the time. Okay, that is always in the microsecond, very minute fraction of second it has going to be executed. That one also we have to measured in the 8086 microprocessor. Okay, so this is all about execution timing, and that instruction execution timing and addressing modes. So as we'll come to the syllabus, see as per the syllabus, dear all students, all of you observing the syllabus copy, right? So today whatever I have to taught, that addressing modes and instruction execution timing. Okay, so these two topics are comes under machine language instructions. Okay, so today I have to taught addressing modes. In that addressing modes, there are totally two main categories, that is data related addressing modes and branch related addressing modes. So data related addressing modes I taught immediate addressing mode, direct addressing mode, indirect addressing mode, uh, and implied addressing modes. And in the branch related addressing modes I taught indirect and direct for the intra segment and inter segment, four categories. Okay, and in the instruction execution timing, particular table I have to given, just you have to remember those values, because these are the given values in the question paper, and whatever I solved the problems, just you have to go through that problem. Okay, so this is all about your second unit of 8086 microprocessor. So in the second unit, one more topic is there, just segmentation. Actually, they are not kept for your syllabus, just for the segmentation. I have to explain in 2 to 3 minutes. So I see again in the next up to the this here I have to use the flag register. So flag register already I explained: sign flag, zero flag, parity flag, carry flag, auxiliary carry flag, overflow flag. All 9 flags I have to execute it just to go through it. After that, uh, I will move to one of the topic. Actually, it is not for your syllabus. Segmentation. So segmentation is very important for your lab point of view. So in that, see here I have to show you one complete memory. In that memory, I have to make breaks into different sub parts. So this is the one entire 8086 memory. Here I have to breaks into sub parts. The first part I call it as code segment. Second part I call it as stack segment. Third part I call it as data segment, extra segment. Okay. So ES, DS, SS, CS. CS is for code segment, SS is for stack segment, DS is for data segment, and ES is for extra segment. All these segments you have to study in the architecture of 8086, right? So these segments are looks like this in the memory. So entire one memory we have to get we have to get separated into sub memories. Those are nothing but we call it as segmentation. Segmentation is nothing but what? These are the sub memories present in the main memory. Present in the main memory. The main memory is 8086 here, and the sub memories are code segment, stack segment, data segment, extra segment, ES, DS, SS, and CS. Okay. So this is the just segmentation, because this is very important for your lab point of view. So in the segmentation, meaning divided into that locally different parts. So that is 2 raised to 20 bytes of memory in the 8086 for 20-bit address bus. And for the physical addresses, we will have a 20 bits. And also it is not possible to work with a 20 bit at a time. So for that, we have to make it as a separate segmentation, separate parts of all 20 bits as our requirement. And based on that, make it as a half of that memory or 1/4 of that memory. So to avoid the complexity and the and to easygoingness of the program execution, we have to use this segmentation. So that segmentation explanation only here, just you have to go through it. For example, if it is 16 bits and with the 4 bits of offset address, so the address bus or a data bus is totally 20 bits. Okay. So 20, but our optional codes are 16 bit. Microprocessor is 16 bit. So 16 bit along with we have to add 4 offset address. So it totally becomes a 20 bits. 16 plus 4, it becomes a 20 bits of physical addresses. Okay. So that segment address, offset address, and physical address, one example I have to given here. So this is this much you have to study in the second unit of microprocessor. Okay, dear students, by today I have to cover second module. Okay, please go through it. Very easiest topic in the second module. Just architecture you have to study, internal operations you have to study, addressing modes, and execution timing. 4 to 5 topics. Very easiest one. Entire clear dictate to dictate notes I prepared and I given to you. Go through these notes. Still you have 30-minute time. Okay, just to go through these notes for the second unit, and you have to note down anywhere you are getting a difficulties or anywhere you are not understanding a particular concept. Please, you have to ask me. And today evening 5 to 6 sorry 6 to 8 o'clock I am available. So whatever the doubts is there with you from unit number 1 and unit number 2, make a note down. And those difficulties, those problems, those not understandable topics, please discuss with me today evening at 6 to 8 o'clock. 6 to 8 o'clock, message me, call me, or send me a one Zoom link and take me in the link. You ask the questions, and whatever you are facing, discuss with me and get the solutions. Okay. So still 30 minutes you have. So you have to study these notes up to 30 minutes. Okay. So I'll stop it here, my lecture. So with this 30 minutes, don't waste the time. Just to go and study whatever I covered today. Okay. I'll stop it here. Any questions?
No, sir.
No, sir.
Okay, thank you. So please don't waste the time. This 30-minute very well defined notes I have to prepare. So you go and check in any of the textbooks. This much data is not available. So to the point to point, 100% accurate data is there in these notes, whatever I have to prepare. Don't miss it. Just to go through it. Do well study. If any doubts or questions, let me know. So thank you one and all. I have to stop it here. Just to go for again 30 minutes for the study. Thank you again.
Thank you.
Thank you, sir.